Oh, something's changed on my screen.
Careful, bring on your screen.
There we go. All right. We did this one together. The next one you were looking at, and some of you already had it, some of you needed to change a little bit, was a linear. Myra, what do you have for your equation for your linear? Equals x. Okay, she says, I don't need any of those numbers. F of x equals x. If we put it into a calculator, I already know what this one's going to look like. It's a line that goes through the origin and looks pretty much like this. So you should have f of x equals, and maybe you have a number in front of that x. Maybe you have something added or subtracted from that x, and that's going to take this line and move it up and down or make the slope different, okay? So f of x equals x was Myra, and that is increasing linear. Uh-oh, you know what? I keep not doing this discrete. What should we do different if it's a discrete? This instead of, instead of having a line, if it's discrete, this should really be a set of points that are lined up in a line. Good. Thank you. Flip the page. A lot of people had trouble. Jerry.
Yes, ma'am.
I just need you to listen, even if it means you have to get something from somebody later, okay? Here we go. Quadratic. A lot of people had trouble with a quadratic. Who finally found an equation that worked? Wyatt.
Yeah, D, right?
D.
I put negative x to the second squared. Negative x squared.
Okay. That's it? He said, I'm not adding anything else. Okay, that works. I was just clarifying. So let's see what happens on when we put that into our y equals. Okay, he has a negative in front. Make sure I do that negative. Now I'm going to press my X button, and now I'm going to square it. Graph. Yep, that worked. Okay, so quadratic has somewhere in your function an x squared, and in order to have a maximum, we need the U shape to go down. Here's what it looks like. X, Y. All right. If you put a number in front, it gets fatter or skinnier. If you put plus something else, it moves it around on this graph. Okay, but quadratic has x squared, and having a maximum, there's a negative in front of that x. Continuous is one we haven't really looked at very much. Who had an idea how to do that? It's come up a time or two, but it hasn't been one of the main categories of things we look at. Sketch a graph that is, not a function. Interesting. That's what we need to do. Not a function. Continuous straight line. Okay, so it does need to be a line, but what do we need to do to it?
You need to put arrows. Oh, it's not continuous. Wait.
It is continuous. It is a straight line, but what it's not is a function. There's only one case. Anybody an idea? All right. Here's what it looks like. It's going to be a vertical line. Oh, those sneaky guys. You had one of your shapes that looked like that in the envelope. Because what happens if I do a vertical line test on this? it'll hit it in a couple of places. Now, the way that function looks like in function notation is f of x equals, you got to look on your graph and say, where is that on the x-axis? Here's 0, here's -1, here's -2. So that equation doesn't have an x, it's just f of x always equals -2. So it's -2 over here, -2 over there, -2 over there. So continuous straight line, not a function. All right. Yeah, we were going to look at talk to talk, but that is a big, huge box of things, and I think we're good right now. All right. What we're going to do is we have things to collect. You have that homework packet. Some of you are done or close to done. Some of you have more stuff to do. Right now we need books up in that cupboard, calculators and rulers over. I'll put them closer to the books. If it's ready to turn in your book, I can also put it in my turn-in box, Andy. Andy, you can also put it in my turn-in box.
Where's that?
Over there by the hand sanitizer. Calculator.